In this lesson, we want to see how to do some basic switch configuration. For example, when the switch first boots up, it has a prompt that says something like switch. We might want to modify that. We might want to give the switch a host name. So when we're working on that switch as opposed to another switch, we're going to be able to see some sort of identifier on it so we know the device on which we're working. We probably also want to set up things such as a password. We might want to encrypt passwords. We might want to set the timeout for a remote terminal session or a local terminal session. We can also do things like configuring a banner. When somebody connects into the switch, they can get a message displaying such as, "Welcome to switch number 1." Or maybe we want to have some sort of a maintenance message pop up as the banner. This switch is going to be down for maintenance on Friday from 2 a.m. to 4 a.m., something like that. Or maybe we want to have a warning to tell people that are not authorized, do not connect to the switch. And after we make our configuration changes to the switch, they're active immediately. However, if we were to power the switch off and back on, those changes would be lost. By default, those changes that we make, they're in RAM. They don't survive a power cycle. So we also want to see in this lesson, how do we save our configuration? How do we save what is referred to as our running configuration to NVRAM, non-volatile RAM. Non-volatile RAM, it does survive a power cycle. We can copy what's in RAM over to NVRAM, reboot the switch, and we boot up with that saved configuration.
If we have multiple Cisco Catalyst switches in our network, and we probably will, we would want to name those switches differently. So when we're sitting at the console of one switch, I know I'm at one switch instead of another. We don't want to just see the default host name of switch. Here's how to change that. Let's go into global configuration mode. We can do a conf t, and we can use the command host name. Host name followed by whatever name we want to give this switch. Let's say that this is going to be SW1. In the real world, you might want to name this based on the building, the location, maybe a specific floor of a specific building. If you have lots and lots of switches to manage, you should probably come up with a naming scheme, in fact, and make sure your switches and routers are named according to that naming scheme. But here, we're just going to call it SW1. Notice that instantly, as soon as I press enter, the host name immediately changes from switch to SW1, and that's how we change the host name. Because we're sitting at the pound sign prompt right now, that tells me that we are in privileged mode. It would be a greater than sign prompt if we were in user mode, but we're at the pound prompt. We're in privileged mode. This means that we can give commands that we couldn't give from user mode, such as look at the running configuration, such as doing configuration, but we probably want to password protect access to get into this privileged mode. And we've got a couple of primary commands for doing that. We could set up an enable password, or alternately, and what we will probably be doing in the real world, is we will be setting up an enable secret. But let me show you both approaches. Let's go into global configuration mode, and I'll say enable password, and I'll give this a password of Cisco 1. And if I exit privilege mode by saying disable, notice I'm back at the user mode as evidenced by the greater than sign. If I try to go back, I'll say enable, and the password I have to give is Cisco 1. And now I'm in privilege mode. However, if I look at the running configuration, notice this. This is in clear text. Our enable password is in clear text. That could be problematic if somebody sees a printout or they look over our shoulder, they somehow see this in the configuration, they would know the enable password. A preferred way of doing things these days is this. We don't even use the enable password. Instead, we use the enable secret. The enable secret command only shows a hashed value of our password in the running config. It's not even an encrypted string, it's a hashed string. So it's a fingerprint. It cannot be reverse engineered, in other words. Here's how we set that up. Let's do configure terminal, enable secret this time. And I'll say that the password is Cisco. If I look at the running config right now, we have both an enable secret and an enable password. Here's the rule. If we have an enable secret configured, we're going to be ignoring the enable password. In fact, in the real world, we probably will never give the enable password command. That's an older command that goes back several versions of Cisco iOS when it was primarily used. For years now, we've been using enable secret. And notice this string, this 5 tells us that this string, it's not an encrypted version of the password, it's a hashed version of the password. This is a 128-bit MD5 hash value. This is not an encryption. We cannot decrypt this. It's just a fingerprint. It's the result of a mathematical algorithm executed on our password of Cisco in this case. Let's prove that it works. Let's back out. I'll say disable. And when I try to enable again, I'll give the password of Cisco instead of Cisco1. In fact, I really don't need that enable password anymore. I'll just get rid of that. And we've now protected access to our privileged mode by creating an enable secret password. Once we're logged into our Cisco Catalyst switch, as long as we're active in giving show commands and doing configuration, as long as we have some sort of interactivity to the switch, we're going to stay connected. But if there is an extended period of inactivity, we may be disconnected. And that could be a good thing for security purposes, so we don't walk off and leave ourselves logged into privilege mode, allowing somebody to come behind us and maybe do bad things. What we can do to change that inactivity timer, or the exec timeout as it's called, is to go into line configuration mode. Let's do that. Let's go into global configuration mode first, and we'll go into line configuration mode for console 0, our console line, and let's say exec-timeout. And we could give a couple of values. We could say a number of minutes followed by a space and then followed by a number of seconds. For example, we could say something like 5 space 30. That would be 5 minutes and 30 seconds of inactivity. If you just want to specify minutes, you could do that. You could say just 5 minutes, and you see that context-sensitive help tells us we could just press enter there, no need to give seconds. What's dangerous is this. If you get the order of these numbers mixed up, you might type in something like exec timeout 05, thinking you're specifying 5 minutes and 0 seconds, when actually you're specifying 5 seconds, and that's not very long. So be careful with that one and leverage context-sensitive help. What I normally do is just do 00. Now that's not saying an infinitely small amount of time. 0 says that we have no inactivity timer. We can stay logged in indefinitely. And I do that primarily because I'm working on lab equipment, but if you were in a production environment, that would probably not be a good idea. But if you're working on a home lab, just to keep yourself from getting timed out every few minutes when you walk away, you might want to do an exec timeout 0, or as I've done here, exec timeout 00. And I've only done this for the console line. I would also want to go into line configuration mode for my VTY lines. I could say line VTY 015 and give the same command there.